In this video, we will be focusing on transformations. And our first unit on transformations, we'll be looking at translations. So let's get all of that vocabulary cleared up here. Okay, so a transformation is an operation that maps an original figure called the pre-image. Pre meaning beginning, okay, onto a new figure called the image. And I don't know about you guys, but sometimes that sounds confusing to me because I'm like, okay, that's the image. Pre means the first one. So pre-image is our beginning of our diagram that you'll see drawn, and then the image is the second one. So on our graph to the left, you'll see triangle ABC is the pre-image, and I'm going to put first here so I know that that's the beginning. And triangle A prime, B prime, C prime is the image. And I'll put second there so we know that's our second one. And we use the word prime. When you see those little tick marks, you're going to say prime. Just so because we're going to have two A's in our picture, and we need to know, well, which one's the first one and which one's the second one. So you'll notice over here the triangle that has triangle ABC that does not have those little tick marks, that's the first image. And the one that has the tick marks is the second image. So you'll always know which one was the original, but you have to look for those little tick marks. Okay? A transformation can change the position. And in elementary school, you heard that as like a slide, right? You could slide it over. So we're moving it from its original. It changes its orientation, which would be like, in high school we say rotate, but in elementary school they said turn. So we had slide, turn, right? Or changing its size. And that's when we get to what we call dilation in high school. And in the middle schools we called it stretch and shrink. So, you know, that I'll try to use both of those vocabulary words just to kind of help trigger some of those memories from the other grade levels. Okay, rigid motion. That sounds fancy, doesn't it? Okay, so rigid motion, it's a kind of long definition, is when a transformation, remember a transformation is any change that we do here by sliding it, turning it, or making it a similar figure by changing its size. So any time that it's moved somehow, but it preserves the size and shape of a figure. So a rigid motion, I can't take a triangle and just turn it into a star. Okay, that's not what we're looking at here. It's going to have to be a similar figure to the pre-image. Shape of a figure. Here we go, figure. All corresponding sides and angles of the pre-image are congruent. And I'll try to define and help explain what corresponding means throughout the lesson, okay? But we did hear corresponding when we were talking about parallel lines and transversals and what corresponding angles meant. So I'll try to make sure that I use that correct vocabulary in this lesson, okay? So examples, again, are of rigid motion is our translations, which are your slides. Reflection. Oh, I forgot that one. Reflection. Like, that's the flip. Oh, I knew I was going to forget one. And rotate. So we have rotation. Let me go ahead and spell all that out. So translation is the slide, reflect is the flip, and rotate is the turn from our elementary school. Okay, so I'm excited. Let's go ahead and start with our first transformation, which is called translation. Okay, again, A translation is a slide. That's the term used in elementary school. So please don't panic. You know, you've seen this before. Of course, maybe not at the same level because we're seeing it on a coordinate plane. You might see it look a little bit different. But if I use the word translation, just think, okay, I'm sliding it over. I'm not changing the size, the shape, or anything of the pre-image. I'm just going to scooch it over. And it's the same old X before Y, walk before you climb, okay? So here we go. What does translation mean? Here's its fancy vocabulary. It means to vertically and or horizontally slide a figure. Oh, I wrote way too big there, didn't I? Okay, let me get my hand out of the way here. So vertically or horizontally, that looks kind of like an H there, but that's an N. I'm sorry, I got a little wild. Okay? So we're sliding it using our X before Y, the walk before you climb. Okay, so we're going to slide it to the right or left, slide it up or slide it down. Coordinate notation. So the fancy way to write this is we have our X and our Y. So we're going to tell you, okay, whatever your original X, that's an arrow, sorry. Whatever your original X value is, I want you to add or subtract H value. So we're going to tell you exactly which direction to move on the horizontal path, okay? And then we're going to tell you, okay, add or subtract K to your Y value. So the best thing about this is they're going to tell you exactly what to do, and we're just going to follow those rules, okay? H represents your horizontal shift. Just like you've heard the horizontal shift, and you saw the H and K last year when we were looking at functions, okay? And then K is your vertical shift. And this vertical and horizontal shift also shows up again in Algebra 2 next year when we're dealing with like vertex form. So this is good for us to keep reviewing these, especially when I see stuff that shows up in Algebra 1, they showed up in geometry, and again in Algebra 2. So there's that connection there that it's important that we really focus on when we see standards that keep showing up over and over again, okay? Alrighty, so are you guys ready? We are going to do our first transformation to a rectangle here, and we're going to translate it. Okay, we're going to slide it. So let's kind of review here. I want to go ahead and write this off to the side. You're not doing anything brand new here. You guys know how to graph a point. You walk before you climb to graph a point. Okay, so remember X before Y, walk before you climb. Okay, so first step is we need our pre-image. We need to know what we're dealing with here. You'll see it is not given here. We have to go ahead and draw that first diagram. So they told us rectangle QRST with vertices of -6, 1, and they give us their ordered pairs. So that is your pre-image. You'll notice it does not have the little tick marks, so that's not our original. So walk before we climb. I'm going to walk 6. Since it's negative, I'm going to go left. 1, 2, 3, 4, 5, 6. Down 1 because it's negative. Okay, and I'm going to label that. That's my point Q. So let me go ahead and add this. Remember, if you walk to the right on the x-axis, that's positive. If you walk left, it's negative. If you climb up on the y, it's positive. When you climb down, it's negative. Just to help you out there if you forgot your directions. So there we are. We've graphed our first point. Let's keep going on. -3, 1 is my next ordered pair. So from the origin, I'm going to start, and I'm going to walk before I've climbed. So I'm going to go, oh, you can't see it. So starting at the origin, I'm going to go left 1, 2, 3. It's +1, so I'm going to go up put my point, label it R. I'm going to continue this, positive 1, negative 5. Remember to count the spaces, not the lines. And then negative 2, negative 7. Oop, I forgot to label it, didn't I? Make sure you're careful on that labeling. I've even tried, like, okay, I'll just put my points and then label, and then I usually make a silly mistake and, like, label them incorrectly. So it's, for me, I have found that it's easier to label them as I go. But, you know, you do what works best for you. As long as you're getting it right and you understand what you're doing, you're perfectly fine. I forgot my school ID. I know I say use your ID as a straight edge. Well, I forgot mine in my car, so I just found this giant paper clip. So any kind of straight edge works here. You have your rulers, your protractors, you have your ID, just whatever works best. Do straight lines, okay? I like pretty diagrams. Do not give me a rectangle that you just kind of free-handed and eyeballed and it's all squiggly, okay? That's not what a rectangle is. A rectangle has to have straight sides and 90-degree angles, so be very careful. Now, obviously, I made a little mistake there, but, you know, make it look good. We're practicing to be, you know, kind of professionals and have good work, okay, if that makes sense. Okay, so there's our pre-image. Now we need to do our image, and they are going to tell you what to do, so don't stress. They're telling us in coordinate notation, this is what I want you to do to your coordinates, just like function notation in our algebra. Like, they had to tell us what they wanted us to plug in for x, and then we wrote it in function notation. Same thing here, you guys. They're telling us what to do. So they're telling us, add 5 to all your x's. So I'm going to write that right here. And I forgot to tell you, because I'm a mess sometimes, is 2 colors, especially if you have color pencils, are really good for this lesson. So you can say, okay, this is my original, or this is my pre-image, and this is my image. I will be better at that, I promise. So they're wanting us to add 5 to all of our x's. Now for me, I like to do all of my x's and then all of my y's, but you do you here, whatever works best for you. So I'm going to add 5 to negative 6, which is negative 1. I'm going to add 5 to negative 3. Whoops. Negative 3 plus 5, yes. And I get 2. Make sure you're labeling it here, because I always want to go here, here, here. And I'll put my R on the wrong one. Alright, and then for S is next. 1 plus 5 is 6. And negative 2 plus 5 is 3. Now, you don't have to do that. You can do all your ordered pairs, you know, together, but I'm just trying to get my brain to focus. Okay, I want you to add 5 to all your x's, then add 7 to all of your y's. So I'm going to put plus 7, plus 7, plus 7, plus 7, and then I'm just going to solve that. So you'll see I'm not even trying to do my diagram right now. I'm just going to get them all written down, and then I'll plot my new points. So I get 6, 8, 2, and 0. Okay, so you could absolutely do a translation without this diagram. You wouldn't even need it. You could just say, okay, this is what I'm supposed to do to the ordered pairs, and write down your new ordered pairs. Okay, so you can have these questions like on your SAT with or without a coordinate plane. Okay, so just be aware of that. All right, and then I'm just going to graph, so negative 1, 6, 1, 2, 3, 4, 5, 6, and that's Q prime, and 6, 2, 1, 2, 3, 4, 5, 6, 1, 2, that's S prime, 3, 0, 1, 2, 3, walk nowhere, that's T prime, and then 2, 1, 2, 1, 2, 6, 7, 8 is R prime. Okay, and then we connect those. Feel free to speed up, rewind, pause, whatever you need to this video. It will always be up on my Google Classroom or on my YouTube page for you to review. So if you go on and you ever see this again in your other classes and you're like, oh man, you know, I really remember how Miss H did this, and you're always welcome to go back and look, even if you are in Algebra 2 or in Pre-Calc, things like that. I know it shows up again in Pre-Calc, okay? So always, always use this stuff. Right, not too bad, right? So again, I'm going to go through these. You can speed it up if you need to. If you're, if it's clicked and you're like, okay, I got this. If not, slow it down, rewind it, whatever you need to do. So you notice the first thing I did on this next problem was I looked for the coordinate notation. Tell me what I'm supposed to do here, right? And so it's telling me that, oh my goodness, Miss H. First, I need to graph my pre-image. I got a head here. 3, 4, 5, 6, 7. 1, 2, 3, 4. Ooh, I almost went the wrong way. It's -4. 1, 2, 3, 4. I didn't bring my whiteout home with me, so I just know I'm going to end up making a silly mistake. Okay, up to -1. So walk 2, down 1. And that is C. And 4, 6. 2, 1, 2, 3, 4. -6. 1, 2, 3, 4, 5, 6. And that is E. So we've got a little triangle here. There is my pre-image. Okay, now I'm going to look at the rule, and the rule tells me to subtract 3 to all of my x's and add 8 to my y's. Alrighty. So for C prime, it would be 2 minus 3 is -1. 7, 1, 2, 4, 4. Okay. So I've subtracted 3 from all my x's, added 8 to all my y's, and now I can graph. -1, 7 is C prime. 1, 2 is E prime. And 4, 4 is D prime. And if you make a silly mistake, like your eyes will catch it, because you're going to look at that and be like, that triangle doesn't look right, because it's supposed to look exactly like the pink one there, or my pre-image, just moved, like it slid over. So I've gotten to where I can notice it, like, wait a minute, that's off just a little bit, and then I'll go back and count, and like, oh, okay, I counted 3 instead of 4. So you'll get, the more you practice this, where you can, look at it, like, after you're done, before you just, like, flip the paper over and go, just kind of step back and look at it and be like, yeah, you know what, that does look like, I could take this pre-image and just slide it right up here and it would fit perfectly. Like, let me see if I can find one that I messed up on. So, like this one here that we're going to get to on the back, when I first did my notes, you'll notice, see how that was like a perfect square, my pre-image, and then when I graphed this one in pink, it was kind of wonky, and I was like, oh, okay, I think I messed up, I counted wrong, and I just went back and fixed it. So, pause for a second before you just jump to the next problem, just kind of lean back and look and say, okay, yeah, that looks right, or maybe I counted wrong, okay? Alrighty, so we're going to practice 2 more and then move on. Again, feel free to pause this video. If you want to pause it and try these 2 now on your own, go for it, and then you can play it or fast forward and see if you got it right. So, you just do what you feel most comfortable with. If not, just go ahead and follow along with me and we'll solve them together. Alright, here we go. I'm going to go ahead and highlight on both of these because that is the most important thing. I need to know that rule because that's telling me what to do. Okay? Alright, let me get my pre-image here. Remember, pre-image is our beginning. That's the order pair given to us. So it's -4, 7. 1, 2, 3, 4. 1, 2, 6, 7. And that's J. Don't forget to label them. Label, label, label. 0, 8 is K. -1, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 1, 2, 3. And if you need to highlight your X and Y axis, I kind of think sometimes I need to, because they're kind of hard to see. It's hard for me to find the origin sometimes. So if you're looking at that and you're like, oh, maybe I started in the wrong place, or I can't see those crosshairs there of our axis, you can highlight those. So, like, if you need to highlight that to begin with, because it kind of makes my eyes go cross-eyed sometimes looking at them, go ahead and do so. Okay, so our ooh, I almost missed the word there, didn't I? Our coordinate notation. Coordinate notation tells us we're adding 2 to our x's and subtracting 2 from our y's. So plus 2 minus 2, plus 2 minus 2, plus 2 minus 2, plus 2 minus 2. So I've got my pre-image built here. Ooh, better figure this out first. So I'm going to add 2, so negative 4 plus 2 is negative 2, and then 5, 2. From up here, negative 5 plus 2 is negative 3. 3 minus 2 is 1. So you've got to do a little bit of work here. Grab your calculator if you're not confident, especially with those integers and those signs, because we don't want any silly mistakes here. Okay? All right, and then we'll get to graphing. So negative 2, 5. L prime. Negative 3, 1, M prime. 2, 6. K prime. And then I'll make my connections. I'm kind of pausing, taking a step back. Does it really look like it's been, that I got it right? It looks good. Okay, so I have my pre-image, and it's been translated 2 to the right and down 2, and I get my image. Okay. I'll highlight my X and Y axis. Well, I kind of go, look how I can't even highlight. Okay, so we get 1, 7, so 1, 2, 3, 4, 5, 6, 7, and that's W. 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 0 is Y, and Z is negative 1, 2. So there's my pre-image. It looks like a big square here. It doesn't have to be perfect, but it needs to be as close to perfect as we can do. Alright, now, I almost forgot that last time. I'm going to have a new set of ordered pairs with my image, and using this rule here. So negative 7, so I'm going to subtract 7 from all my x values. And, woo, what does that mean, Miss H, right? So what that means when if they would just have an x or just a y, is they want you to do nothing to the y value, okay? So keep your y's the same. Don't change those. So if it makes you feel better, you can go ahead and say, okay, well, W would be 7, W prime, and then X stays 5, Y would stay 0, Y prime, and Z prime would stay 2. So you see, I'm not changing the Y values. That's what that means. Do nothing to them. And I guess you could put plus 0 or minus 0. But normally you just see variable there, just Y staying there. Okay, I'm going to go ahead and subtract 7 from all of my x's. Negative 6, negative 1, negative 3, negative 8. And then I can begin graphing. Negative 6, 6 is w prime, negative 1, 5, negative 3, 0, y prime, negative 8, 2, z prime. So it's been slid to the left 7 units. 7 units. And there we go. Looks pretty good, doesn't it? Not too bad of a lesson. Uh-oh, I think I forgot to label one. Which one did I forget? X prime. Oh, maybe I did. It's just you can't see it there. X prime. Okay. Moving on, we have another vocabulary word. This looks a little bit crazier, but you know, I promise you it's not too bad. I'm going to highlight this here. Vectors. Vectors. Makes me think of, I've heard that before. Oh, I think of like the Stranger Things. My daughter's always watching it. Oh no, that's Vecna. Sorry. Okay, vectors. What is a vector? So let's just kind of assess this real quick. If you look at the diagram, you'll see the vector is drawn. This is a ray. Remember, a ray is a half line, so it has an endpoint, or where it begins, and then we really want to pay attention to the direction of our ray. So I'm going to add a little note here. Watch the direction, watch direction of your vector, which is a ray. Okay, is it going up? Is it going down? Is it going left? Is it going right? So how we know is we need to focus on two things. We need to focus on where's the endpoint and where's the arrow pointing to. Okay, so sometimes it's kind of hard, especially how the copy machine does this, but just pay attention and ask questions as you go, okay? Alright, so the fancy vocabulary or definition for vectors is a quantity with both direction and magnitude or size. Okay, fancy definition there. So what does that mean? Okay, a vector is represented in a coordinate plane by an arrow drawn from an initial point, so from a beginning, initial means beginning, in this case P, that's the initial point, to what we call a terminal point Q. A vector is denoted as a ray, ray PQ. Okay? And is read as vector PQ. Okay, so I know you're like, wait a minute. That sounds a little confusing because it also looks like a ray, right? So it looks like a ray. It has an endpoint and where it begins and then it goes forever in a direction. But you'll notice that the ray is actually put from the begin, but between 2 points. So the normally we don't see a point at the end. It continues on forever and ever, right? But with a vector, it's going to give us a, how would I say it? Like some boundaries. Okay, we want to look between these 2 points. And we're still looking at a horizontal and vertical changes. Okay. All right, so a component in the component form of a vector, that's just a fancy way to write it, okay, is written as vector PQ equals AB, and these, like, it looks almost like inequality symbols, okay, where A is our horizontal, that's our X, walk, and B is our vertical, that's our climb. So they're still going to tell you, or they're going to be asking you, what's the horizontal and vertical change in our vector. The trickiest part is just paying attention to the direction that our ray is traveling, our vector is traveling, so we know if we should have positive or negative signs. So for me, I think the trickiest part is knowing when it's positive and when it's negative, okay? The component form of the vector to the right, it should be to the left, right over here, is we're going to start with vector PQ, and I see that it's traveling. I'm going to do walk and climb, so I start at the beginning here, at the initial point, and as to get to Q, I'm going to be moving right and up. Well, right and up are both positive. So you count your spaces. You can draw your triangle here if you need to, and my change is positive 4, up 7. 4, 7. Okay. So here we go. Let's practice some of these. Again, I need to look at my initial point and the terminal point. And so this one is traveling to the right and up, to the right and up. So vector WV, and the component is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're counting the spaces, 9 and up 3. So 9 for a horizontal, 3 for a vertical. Okay, again the next one. So this time we're starting over here at the right, and at our initial point, and our terminal point is to the left. So you'll see it's moving to the left and up. Well, left is negative, up is positive. So 1, 2, 3, 4, 5. Oops, let's go ahead and write that. And you'll notice I'm starting with the initial point. I put that letter first, and then I put my terminal point. So that's going to help explain. So again, without this, like, we could draw it, at least have an idea of what it should look like. Okay, and then it is -5 to, so it went left 5, up 1, so -5, 1. All right, initial, terminal. So again, that's going to help me know, is it positive or negative. So I'm going to go ahead and write that. If it's going to the right, it's positive, left is negative, up is positive, down is negative. Okay, so vector SR, and for me it helps me to draw, kind of connect these. So I'm moving down and to the left, down and left. That's telling me they're both negative, and we count your car spaces there, you guys. You get -2, -11. Be careful you're not using parentheses, because that would tell me an ordered pair. This is not an ordered pair. It's not a point. The -2, -11 is not a point. It's the component form, the horizontal and vertical components to our vector. Okay. Honestly, it's the directions that it's traveling, right? It's going to the left 2 and down 11. All right, here we go. Initial point B, terminal point C of vector BC, down and to the right, down and to the right. So that would be -2, +2. So just make sure you do have that in XY form, your horizontal to your vertical. Yep, I said it right. Okay, I'm always like, ooh, because I don't want to get confused with rise over run, right? Okay, my initial is M, and my terminal point is N. So you'll notice this one is just going straight up. There's no horizontal change, so you just put 0. And our vertical component is 6. Okay. Our initial and terminal points are H, G. And you'll notice this time it's just going straight left, so there is a horizontal component of -11, which if you count them, right, we went to the left 11, but there's no vertical component, so our y is, or our b value, sorry. I keep saying x and y, but I should be saying a and b. My a is -11, my b is 0. Because again, it's not an ordered pair, so I'm not using parentheses. Alright, you guys, we'll get these notes taken, and we'll get some practice in. Bring all your questions to class.